thermodynamics and statistical mechanics problem, which is asked in CSR June 2011, 5-mark question. A gas of n non-interacting particles is in thermal equilibrium at temperature T. Each particle can be in any of the possible non-degenerate states of energy 0, 2 epsilon and 4 epsilon. The average energy per particle of the gas when beta epsilon is much less than 1 is 4 options are given. So we have to find out the correct one. The solution to this problem, so what is given? Given 3 energy levels, they are non-degenerate. So this is epsilon 1, which is equal to 0 epsilon. Okay, so this is the ground state. Energy, and there is another state, another energy level, that is epsilon 2, which is equal to 2 epsilon. This is the first excited state. And the epsilon 3 is equal to 4 epsilon. So this is second excited state. So these three things are given. Okay, excited state, energy. So this is also energy. Okay, now so let us take n1, let us assume this be the number of particles in energy level, that is state epsilon 1, that is equal to 0 epsilon, and let us assume n2 be the number of particles in energy state epsilon 2, that is equal to 2 epsilon. Similarly, n3 be the number of particles in energy state epsilon 3, that is equal to 4 epsilon. So we have 3 levels, and let us assume n1, n2, n3 are the population on these 3 energy levels. So from the Maxwell-Boltzmann distribution formula, Maxwell-Boltzmann distribution formula, so for Ni, okay, let us Ni be the number of particles in the state Ei or epsilon I. So this is given as Ni is equal to Gi e power minus beta epsilon I. That means for ith energy state, Ni be the number of particles distributed on that state. Okay, so this is given, and also it is given that all the states are non-degenerate. So which means the degeneracy factor Gi is equal to 1 for all I. That means, so there are three levels. So for n1, it is equal to G1 e power minus beta epsilon 1. Here, since ground state is non-degenerate, so G1 is equal to 1 and epsilon 1 is equal to 0. Therefore, n1 is nothing but e power 0, which is equal to 1. Similarly, for n2, it is G2 e power minus beta epsilon 2 G2 is also equal to 1. Epsilon 2 is equal to 2 epsilon. Therefore, it is equal to minus 2 beta epsilon. That is N2. Similarly, N3 can be written as G3 e power minus beta epsilon 3. This is epsilon 3. So G3 is also equal to 1. Epsilon 3 is equal to 4 epsilon. Therefore, N3 is equal to e power minus 4 beta epsilon. So this is done. Now the total number of particles. See, there are three levels. So first level N1 number of particles, second level N2 number of particles, third level N3 number of particles. That gives you the total number of particles N, because it is given in the problem the gas of N non-interacting particles. Okay, so therefore the total number of particles is this. Now we can calculate the average energy per particle. So let epsilon bar be the average energy per particle of the gas, which is given as sum over I. This is Ni epsilon I by total N. Now which is N1 epsilon 1, N2 epsilon 2, N3 epsilon 3 whole divided by N1 plus N2 plus N3. So already we have computed N1, N2, N3. Epsilon 1 also known, epsilon 2 is also known, epsilon 3 is also known. By substituting, we will get the answer. So N1 is 1, N1 is 1, so 1 into, so epsilon 1 is 0. So N2 is this one, that is e power minus 2 beta epsilon into epsilon 2 is 2 epsilon plus e power minus 4 beta epsilon into 4 epsilon whole divided by 1 plus e power minus 2 beta epsilon plus e power minus 4 beta epsilon. So this is what you will get. Okay, so let us simplify this. So among these, so we can take 2 epsilon common and 1 e power minus 2 beta epsilon if you take outside, you will get 1 plus 2 e power minus 2 beta epsilon whole divided by 1 plus e power minus 2 beta epsilon plus e power minus 4 beta epsilon. Also it is given that we have to calculate the average energy per particle of the gas in this limit, that is beta epsilon is much less than 1. So if you take that into account, so then e power minus 2 beta epsilon will be approximately equal to 1. E power minus 4 beta epsilon, that also approximated to 1. Therefore the average energy per particle will become 2 epsilon into 1 plus 2 whole divided by 1 plus 1 plus 1. Therefore 2 epsilon into 3 divided by 3. Therefore 2 epsilon is the correct answer. So answer for this question is option 1, that is first one. Okay, so we can also derive in the alternate way through formula method. The formula method is, so we know the internal energy, so this is an alternate technique. The formula method is, so u is equal to minus partial by partial beta of logarithm of z, where z is the partition function. Okay, partition function, it's nothing but sum over states, so which is equal to the, what are the states? So there are three states, so e power minus beta. So the formula for discrete state is sum over I gi e power minus beta epsilon I. So we know that g1 g2 g3 are 1 and epsilon 1 is 0, epsilon 2 is equal to 2 epsilon, epsilon 3 is equal to 4 epsilon. So once if you substitute, you will get terms like this, that is 2 beta epsilon e power minus 4 beta epsilon. So the partition function for this problem is this one. So this is partition function. So look at the previous slide. So this is the partition function. The denominator term is nothing but what? Partition function. So we have computed that. Okay. Now you have to take the logarithm of this. Logarithm of this quantity is logarithm of 1 plus e power minus beta 2 beta epsilon plus e power minus 4 beta epsilon. By taking the derivative with respect to beta, logarithm of z 1 by 1 plus e power minus 2 beta epsilon plus e power minus 4 beta epsilon into this quantity, derivative of this quantity, that is derivative of 1 is 0, then derivative of this term is minus 2 epsilon e power minus 2 beta epsilon, because we are taking the derivative with respect to beta. The same manner, minus 4 epsilon e power minus 4 beta epsilon. Okay, so therefore if you take minus 2 epsilon e power minus 2 beta epsilon, you will get 1 plus 2 e power minus 2 beta epsilon whole divided by 1 plus e power minus 2 beta epsilon plus e power minus 4 beta epsilon. So once you substitute here, this is nothing but minus into minus plus, so 2 epsilon e power minus 2 beta epsilon, okay, into 1 plus 2 e power minus 2 beta epsilon whole divided by 1 plus e power minus 2 beta epsilon plus e power minus 4 beta epsilon. Once again, if you apply the same thing what we have done in the previous page, these approximations, because we have done this, we have calculated this. So if you apply this, you will get this as an answer. So the answer for this problem is the first one. So this is alternate way of doing this problem. Thanks for watching this video.
Thank you for watching the video. If you liked the video, please press the like button. If you are interested in receiving information about new videos that are posted, click the subscribe button. If you have any comments or questions about the content discussed in the video, please leave them in the comments section below.